Hi everyone, so in today's video we're going L'Hospital rule. So before we get started, first we want to see the indeterminate forms. So the three most common indeterminate forms are 0 over 0, infinity over infinity, and 0 times infinity. Now what that means is, let's say you are trying to find the limit as x approaches a, and we have two different functions and they are dividing by each other. What we can do in this form is we see that we have two different functions, right? F of x and g of x. What we can do is we can do separately. So we can do the limit as x approaches a of just f of x and then see what that is. And then we can also do that for g of x and see what that is. And what we mean by 0 over 0 is if the limit as x approaches a for f of x, if that's equal to 0, and g of x is also equal to 0, then that's 0 over 0. The same goes for infinity over infinity and 0 times pi in the form of f of x times g of x. So I know this is kind of confusing at first, but once we apply it, it'll make much more sense. So for our first question, let's try it out. So we have the limit as x approaches 1, and we have this really ugly function. What we can first do is, what we usually do is plug in 1, right? So we can just plug in 1 into x. So we get 8 plus 1 minus 3 times 1 to the power 1 over 3 times 1 squared minus 3 times 1 plus 2. And we get square root of 9, which is equal to 3 minus 3 over, we have 1 squared minus 3, that's negative 2, plus 2 is 0. So all this, we have the expression 0 over 0. And if we take a look at this expression, it ties back to our indeterminate form, 0 over 0. So when we have this indeterminate form, what we want to do is apply L'Hopital's rule. So if we apply L'Hopital's rule, what we want to do is derive the upper function and the lower function. So here we have 0 over 0, and the function here is basically f of x, and the function here is basically g of x. So what we want to do is derive both of them separately. So what I want to do is only care about the first function for now. So to derive this, I get square root 8 plus x. The derivative of that is, so we have 8 over x. That's basically, square root is basically just 1/2. So to derive it, we put the 1/2 out, and we have the inside function, which is 8 plus x times the 1/2 minus 1, which is equal to negative 1 over 2. Minus, we want to derive this, we want to derive 3x to the power of 1 over 3, which is basically just x to the power of 1/3 minus 1, which is basically just negative 2 over 3. After that, we want to derive the bottom function now. So to derive the bottom function, we have x squared minus 3x plus 2, which is just 2x minus 3. Now, we want to do the same thing as we did earlier and plug in 1. So we applied L'Hospital rule, we derived both functions, and now we just try to find the limit. So once again, I'm plugging it in. I have 1 over 2 times 1 over square root of 8 plus 1, which is 9, minus, okay, we are having a lack of space, so let me just put that down here. So we're plugging it in, and then we have x to the power of negative 2 over 3, which is just 1, because if you plug in 1, it's just 1, over 2 times 1, which is 2, minus 3, negative 1, and when we're at this stage, we get 1 over 2 times square root of 9, so that's just 3 times 2, so that's 1 over 6 minus 1 over negative 1. So we get negative 5 over 6 over negative 1, which is the negative sign cancels out. So we get 5 over 6 for our first question. So there you have it. One of the key points to take away is when we first do it, we can just directly substitute in to see what our indeterminate form is, which is 0 over 0. And once we have indeterminate form, we can apply L'Hospital rule. And when we apply L'Hospital rule, what we do is derive the top and bottom function, and then we get our answer as 5 over 6 in the end. Now let's try something else. This time, we see that it is not in a fraction form. So one of the big things I want to talk about is when it comes to L'Hospital rule, notice I wrote here with a red star, must be in fraction form, then differentiate. So one of the things we want to do is if the form is not in fraction form, we want to turn it into a fraction form. So in this case, we have secant x minus tan x, which is not a fraction form. So we want to change that. So we have to rewrite it into a fraction form. So before we start, we want to rewrite it. So I'm not deriving, I'm not applying L'Hospital rule, I'm just algebraically changing the form. So I want to change this into a fraction form. What I can do is I can do it separately. So first I have secant x. To change that into fraction form, remember that secant x is the same as 1 over cosine x minus tan x, and the fraction form of tan x, remember, is sine x over cosine x. And if we simplify that, we see that they have a common denominator, which is, so we can combine the common denominator and have 1 minus sine x over cosine x. So now that we have it in our fraction form, let's actually find the limit. So the limit here, as x approaches pi over 2, so we want to plug in pi over 2. And remember from previous classes in pre-calc, we can draw out the unit circle. We have pi over 2 here, and the coordinates are 0, 1. So sine of pi over 2 is 1, cosine of pi over 2 is 0. So we get 0 over 0. Again, that is an indeterminate form. So what we want to do now is take the L'Hospital rule. So the L'Hospital rule now, what we want to do is again derive the top and bottom function. So what we do is we derive it. So we have 1 minus sine x. So the 1 just cancels out. So I have negative sine x. And to change that into a derivative, that's basically just negative cosine x of the top function. And for the bottom function, cosine x, the derivative of that is negative sine x. And now what we can do is we can find the limit. So the limit as x approaches pi over 2, we have cosine of pi over 2 over sine of pi over 2. And what we get is, again, unit circle, same thing, cosine is 0 and sine is 1. So our final answer is 0. So our limit as x approaches pi over 2 of secant x minus tan x, that is equal to 0. So there you have it. Moving on to our final problem and our hardest problem here. This time we see something even weirder. We see something that's not in fraction form and something that's kind of hard to change into fraction form. We see that this is an exponential function. So what we do here is, notice I put down notes here. We have even more additional indeterminate forms. So earlier, these three are the main ones. But we have additional indeterminate forms, which are 0 times infinity, infinity minus infinity, 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. So here, notice that as x approaches infinity, the x right? If we look at the graph of x, that goes to infinity. And 1 over x, it approaches 0, because as x becomes a larger number, the denominator becomes bigger. And when the denominator becomes bigger, it gets closer and closer to 0, right? So we have, in this case, infinity to the power of 0, which is one of the indeterminate forms. So what we want to do is obviously take L'Hospital rule. But how? This is an exponential function. So what do? So first we can say y equals to x to the power of 1 over x. And when in this scenario where it's hard to change it into a fraction form, what we want to do is we can take ln of both sides, because remember, ln and exponential functions are inverses. So I can take ln of both sides, and to simplify that, we get ln of y. And remember, of basic log properties, the power comes down, so we have 1 over x times ln of x. So once we have that, we can then take the limit of both sides now. So to take the limit of both sides, I'm going to take the limit of both sides. And we want to find basically the limit on the right, and then leave this by itself for now. So let's do that then. We have limit as x approaches infinity of 1 over x times ln of x. Now we can change it into a fraction form, which is basically equal to ln of x over x. So that's a fraction form, and now we can see the limits. So the limit as x approaches infinity for ln of x, that is equal to infinity. And for x, that is also equal to infinity, because remember, the graph of ln of x goes like this, and it goes towards infinity. So in this case, we have an indeterminate form, infinity over infinity. So we want to take the L'Hospital rule and derive this function. So we have limit of x approaches infinity. So for the top function, we have ln of x. Remember, the derivative of that is just 1 over x over the derivative of x, which is 1. And to make things easier, that is basically 1 over x. So what do we have here? We have the limit as x approaches infinity of 1 over x, which is equal to 0. Because here, remember, we have 0. As x gets bigger and bigger, the number goes smaller and smaller. So our answer is 0. But remember, we are not done yet, because this is in the form of ln of y. So now we want to convert that back so that y is by itself. So recall that the limit as x approaches infinity of ln of y here is equal to the limit as x approaches infinity of ln of x over x. What we want to do here is we want to have y. So remember the basic rule of ln. So if we have ln of any number, let's say a equals to b, that basically means e to the power of b equals to a, right? So if we apply that knowledge, we get e to the power of this entire limit of ln of x over x is going to be equal to the limit as x approaches infinity of y. And we said y was equal to x to the power of 1 over x, so that's exactly what we're trying to do. So the limit of ln of x over x, we just finished solving it, which is 0, which is the limit as x approaches infinity for y, and that's also equal to 1. So there you have it. That is our answer. And so yeah, that's like the end. So thank you so much for watching. I hope you guys understand a lot more on how L'Hopital's rule work. Key takeaway is first, notice how the indeterminate form is. Later on, if it's indeterminate, then you can take the L'Hospital rule. and apply and derive the fractions. So we derive it separately. Remember, we derive it separately, so make sure to do that, and also make sure to rewrite it into a fraction. And if in rare cases where you can't rewrite it in fraction form, you can always take the ln. So there you have it. Thank you so much for watching. See you guys next time. Bye.